Hi everyone, welcome to Real Numbers Part 4. So in Part 3, we learned how to find the HCF of fractions using Euclid's division algorithm. Now we are going to find the HCF of decimals using the Euclid's division algorithm. Okay, let us take some examples. So let us see one example. Already in Part 3, I explained how to find the HCF of the fractions 2 by 5 and 3 by 4. So this problem I explained how to find the HCF of 2 by 5 and 3 by 4. Already we got HCF of 2 by 5 comma 3 by 4 is equal to 1 by 20, or when it is expressed in decimal we got 0.05. So for better understanding, so I am taking the same fractions. I will convert these fractions into decimals and I will take it as problem. So let us take 2 by 5. So what is the decimal form of 2 by 5? So to get the decimal form of 2 by 5, we have to divide the numerator by the denominator. So here the denominator is 5. Let us divide the numerator. Let us divide the numerator 2 by 5. Then what we will get? So 2 won't go in 5. So let us keep a point. Then we can write 0 here. Then 5 4s are 20. So remainder is 0. So 2 by 5 is nothing but 0.4. So let us take 3 by 4 and express it in decimal form. So we divide the numerator by the denominator. Numerator is 3 and denominator is 4. Divide 3 by 4. So 3 won't go in 4. So keep the point. Then we can keep a 0. So 4 7s are 28. 2 remains. Then keep a 0. Then 4 5s are 20. So we got 0.75. So that is when 2 by 5 is expressed in decimal form, we will get 0.4, and 3 by 4 when it is expressed in decimal form, we will get 0.75. So now I will find the HCF of 0.4 and 0.75. So let us take let us take the decimals 0.4 comma 0.75. What is the HCF of 0.4 and 0.75? So what is the example? So we are going to find the HCF of, the question is find the HCF of 0.4, 0.75. Why I took this example? Because already we found the HCF of 2 by 5 and 3 by 4. So we have the answer 1 by 20 or 0.05. So we converted these fractions into decimals and I took it as a problem, so that you might have understood that in this problem also we should get the same answer. That is the HCF we should get 0.05 or 1 by 20. Let us see how to find. So in finding the HCF of decimals, already I told you Euclid's division algorithm, it is applied to only positive integers. So many times I told in part 1, part 2, part 3. So again I am telling you. So Euclid's division algorithm is applied to only positive integers, but these are not the positive integers. These are the decimals. Then how to find the HCF? So what I have to do? What is the process? Let us see here first 0.4 and 0.75. Let us consider these two numbers 0.4 and 0.75. So what type of decimals are these? Here after the decimal point we have only one decimal place, and after the decimal point here we have two decimal place values. So these two decimals are called unlike decimals. These are unlike decimals. These decimals are called unlike decimals. So in finding the HCF of decimals, the very first step is we have to convert the unlike decimals into like decimals. We have to convert them into like decimals. Like decimals means, so in that decimal numbers, the number of decimal places should be same. So here after the decimal point we have only one place. Here after the decimal point we have two places. So here we have two places. Let us try to write two places after the decimal point in first one. So 0.4 can also be written as 0.40, and 0.75 okay is same as 0.75. Now you see after the point we have two places, after the point we have two places, 0.75. 0.75. Now let us take it as A. So let A is equal to 0.40 now, and b is equal to 0.75. So directly we cannot apply Euclid's division algorithm to these numbers. Directly we cannot find the HCF of a comma b directly. HCF of a comma b, so you can't find directly. So you cannot find directly. So that what I will do now, I will try to remove the decimal point. I will try to remove the decimal point. So after the point, how many digits we have? 2 decimal places. After the point, how many places we have? 2 places. Here also 2 places. So when a decimal number has 2 places after the decimal point, to remove the point, that decimal number should be multiplied by 100. Suppose if any decimal number, if it has 1 place after the decimal point, it should be multiplied by 10 to remove the point. Suppose if it has 3 places after the point, it should be multiplied by 1000 and so on like that. So that here after the point 2 places we have, that's why what I will do, I will multiply this decimal number by 100. That is, here a is equal to 0.40, that's why I will multiply 100 into a. If you multiply this number with 100, the point moves 2 digits forward. That means point will come here and after 40. That means we will get 40. 100a is equal to 40. Then here also you multiply the 2 numbers. So with what number you will multiply a, with the same number only we will multiply b also. With what number a you are multiplying, with the same number we should multiply b also. That is why we are multiplying both a and b by 100 here. So if you multiply with 100, so here point moves 2 digits forward and we will get 75. Now you observe 100a value is 40, 100b value is 75. Okay, now we can find the HCF of 40 and 75. We can find the HCF of 40 and 75 because you know that these are the positive integers. These are the positive integers. So for these 2 numbers we can apply Euclid's division algorithm. So that is, we can apply Euclid's division algorithm for 100a and 100b. So first we will find the HCF of 100a, 100b, and then we will find the HCF of a, b. This is the procedure. Okay, let us find the HCF of 40, 75. So let us find the HCF of 40, 75. HCF of 40, 75. What is the HCF of 40, 75? So to find the HCF, we have to apply Euclid's division algorithm. So by Euclid's division algorithm, so we have a is equal to, dividend is equal to b into q, divisor into quotient, plus remainder, where remainder value it is more than or equal to 0 and less than the divisor. Okay, a is equal to b into q plus r, where 0 less than or equal to r less than d. Okay, this is the Euclid's division algorithm. So we know from part 1. Okay, so now let us apply this Euclid's division algorithm to these numbers. So in the first step, let us apply Euclid's division lemma to these 2 numbers 40 and 75. So here the larger number is 75 and the smaller number is 40. So let us divide the larger number by the smaller number and find a quotient and remainders. So find the unique quotient and remainder. In this 41 the 40. So here 5 minus 0 5, 7 minus 4 3, 35 is the remainder. So here the remainder is not 0. So let it be, first of all you express this decimal, this division in the form of equation, that is in the form of statement of division lemma. That is, dividend 75 is equal to divisor 40 into quotient 1 plus remainder 35. So I already told previously, if the remainder is not 0, we have to further proceed to step 2. So in the step 2 again we have to apply division lemma for the divisor and remainder obtained in step 1. So in step 1 divisor is 40 and remainder is 35. So now for these 2 numbers 40 and 35, we will apply division lemma. Okay, so in this the larger number is 40 and the smaller number is 35. Let us divide the larger number by the smaller number. Then what we will get? 35 on the 35. 40 minus 35 is equal to 5. So of course here also we did not get the remainder 0. Let it be. Express this division also in the form of statement of division lemma or in the form of equation. So here dividend is 40. So dividend is equal to divisor is 35 into quotient is 1 plus remainder is 5. So we will get this equation. Here also the remainder is not 0. That is why again we have to proceed for further step. You know that this procedure should be continued till we get the 0 as remainder. Okay, you know it. Let's continue again. So for what numbers we have to apply the division lemma here? So what are the divisor and remainder in step 2? 35 is the divisor and 5 is the remainder. We have to apply division lemma again for these pair of numbers 35 and 5. So let us take 35 is the larger number and the smaller number is 5. Let us divide 35 by 5. So 5 7 are 35. So you got the remainder 0. That means the process of finding HCF is stopped. So 5 7 are 35. So 5 is treated as HCF. At this stage the remainder is 0. So that this divisor is treated as HCF. Okay. So let us express this in the form of equation. Here dividend 35 is equal to divisor 5 into quotient 7 plus remainder 0. Since the remainder is 0, the divisor is treated as HCF. So HCF of 40 comma 75 is equal to 5. HCF of 40 comma 75 is equal to 5. So what is 40 here? 40 is nothing but 100A. So what is 75 here? 100B. That is, till now we found the HCF of the numbers 100A comma 100B. We did not find the HCF of 0.4 and 0.75. We did not find the HCF of 0.4 and 0.75. We found the HCF of 40 and 75, which are 100 times of these decimals. Okay, that means we found the HCF of 100A comma 100B. So HCF of 100A comma 100B is equal to 5. Then what is the HCF of A comma B? What is the HCF of A comma B? Already in part A I told. So what I told? HCF of M into A comma M into B. If it is X, then the HCF of A comma B is equal to X by M. That means here these two numbers are multiplied by 100. So that to get the HCF of only A comma B, we should divide this HCF by 100. So 5 by 100. If you divide any number by 100, so what we will get? We should keep the point after 2 digits from right side. This is 1 digit. So 2 digits not there, you can keep 0 and you can keep the point here. That means what we will get? 0.05. 0.05. So A comma B means what? A comma B means 0.4 and 0.75. So HCF of 0.4 and 0.75 is 0.05. So here also we got HCF of 2 by 5 and 3 by 4 is 0.05. So these two are same. 2 by 5 is same as 0.4. 3 by 4 is same as 0.75. So we got the HCF of in terms of fractions. If you find the HCF, we got 0.05. So in the form of decimals also we found the HCF, we got same answer. So this is the way of finding the HCF of decimals. I hope you understand well. Thank you very much for listening. Thank you.